Thank you all for being here. My name is Rebecca Shore. I'm the Education and Engagement Senior Program Manager with the Stone Living Lab. Welcome to today's workshop. I'm just going to run through a couple of organizational points and housekeeping items before we pass things off to our first speaker. So, first off for today's agenda, doing a little bit of intros right now, and I'll introduce our speakers. We're going to get a background of nature-based approaches. This is the term that the Stone Living Lab and our partners are shifting to use. So you'll get some background about nature-based approaches as well as Cobble Berms, the focus of today's program. We're going to get a 5-minute break at about the 1:25, 1:30 marker, so you can stretch your legs, grab a glass of water. And then at 1:30, thereabouts, we'll kick off with our Permitting 101 case studies and the role of mass CZM in helping to make this whole process easier, what kinds of resources they can connect you with, and their role in all this. We'll then do a little preview of some of the outreach materials we're creating as part of this project. And then at 2 p.m., we're going to have a Q&A session for half an hour, so you can ask all of your questions that may have popped up during the course of today. In terms of housekeeping items, today's meeting is being recorded. So if you would not like to have your face or your voice recorded, please turn off your camera. You are muted automatically, so you can maintain that, or you're welcome to view a recording at a later date, which will be posted to the Stone Living Lab website. Please use the chat function for asking any questions. Unless you're called upon, then we may ask you to unmute. But otherwise, please maintain questions in the chat. We'll have 30 minutes at the end for that Q&A session. And then you are welcome to generate closed captioning option under the More section of Zoom. So you are welcome to activate those, and captions will be produced live via AI. Just some quick community guidelines as we're all here today. We've got a large group of folks all here eager and ready to learn. So we just want to remind folks of some of the guidelines that we ask you all to follow as joining this meeting. The first one is the term we call it embrace speaking in the first draft. So know that some folks here may be asking a question that popped into their head or answering more off the cuff. So please give some grace to folks if they say something and then need to restate it. Just know that we're all learning together and that this is an opportunity for us to work together and speak together. Assume best intent when folks are speaking and sharing. Please avoid using the chat for side conversations. We want to keep the focus on the presentations. So avoid going into deep conversations in the chat. We really want to save that for our verbal conversation. Be respectful of speakers and fellow attendees. Keep your questions project and topic specific. Be mindful of folks' time. So if you have a question that is going to require a longer discussion, maybe we suggest taking that offline. Any inappropriate language will not be tolerated and will result in immediate expulsion. Annie is very quick on the draw, so please avoid any contention in this forum. And then again, please remain unmuted or muted unless asked to unmute. If you are unmuting yourself at inappropriate times, you will be removed from the meeting. So finally, today's speakers, you're hearing from me right now, Rebecca Shore. You'll be hearing from Kirk Bosma at Woods Hole Group, Leslie Fields at Woods Hole Group, and then Rebecca Haney and Julia Neisel, both from the Massachusetts Office of Coastal Zone Management. And with that, I'm going to stop sharing my screen and we will be passing things over to Kirk to get us started.
Great. Thanks, Rebecca. Can somebody give me a verbal cue? They can see my screen.
We can see it.
Awesome. All right. So I'm going to give a little bit of introduction to, cobble berms, what they are, how they're used, and some of the work that we've been doing at Duxbury Beach Reservation, Stone Living Lab, and Woods Hole Group under a CZM funded grant to really try to understand and monitor these cobble berm approaches, nature-based approaches a little bit better. So first of all, what is a cobble berm? A cobble berm consists of cobble size, typically 3 to 10 inches sediment, constructed at the base of a coastal bank or dune, intended to enhance the natural system, absorb wave energy, and reduce erosion. The range of, the 3 to 10 inches varies, and that's based on the existing grain size and constitution of the beach. Typically, these are put on existing mixed grain or cobble type beach settings, and then also related to the energy from the waves and currents that you might see at a beach location. That dictates what type of size of cobble you might be appropriate for a specific situation. Really, the goal here is to mimic natural conditions at a beach and then enhance that ability of the beach to function and work. So it's not that different from thinking about a beach nourishment project where you might have a lack of sediment or a lack of a sediment source, and you're really trying to enhance the natural system in a way to allow the beach to function uh, better or an improved level. And these really just follow nature's lead in terms of a nature-based setting. So there's many examples of natural cobble beaches and or berms that have occurred in nature. There's a few that I'm showing here, ranging from Oregon to Peru to freshwater lake in Michigan, to more here in the Northeast and in Massachusetts and Maine. And these are naturally occurring. Some of them are what we call composite beaches. So Newport and Stonewall Beach, you can see there's a very sandy kind of beach out seaward. And then as you go into the upper part of the intertidal area and above the tidal area, you'll get more of the cobble berm type setting at those locations. Some are strictly cobble beaches. Lima, Peru is a very cobble beach. Indian Beach, Oregon is a very cobbly beach. So we're drawing from nature, as many of these nature-based approaches are, in terms of laying out a then enhancement to the beach. That doesn't mean that these aren't designed in a way, but it follows what we see in nature and what would naturally be on a beach. Where do you typically want to think about using these types of systems? As I mentioned, one of the key indicators is what's already there, what's naturally there. So this is Coughlin Park in Winthrop, Mass. You can see it's a very mixed grain situation. And some of these beaches vary from summer to winter profiles, but at this particular location, you can see there's a fair amount of cobbles already in the upper part of the profile, meaning more inland. And so that's a good indication that this is a beach that has a lot of natural cobbles already. And so we're looking to enhance that particular setting at this location. Coughlin Park had some pretty significant erosion. This is a pre-cobble berm. So the existing setting, you can see the exposed manhole there. You can see the park right in the background that was being threatened. And so the idea here was to mitigate some of the ongoing erosion. It wasn't necessarily to stop flooding of the park per se under high water conditions. The park can survive a flood condition, but it can't survive the ongoing erosion and loss of space. So what the solution looks like here's the after picture that shows the nature-based approach. This was a hybrid solution. Leslie will talk a little bit more about this later. Consisted of some coir rolls in the back and then a cobble berm fronting that with a lot of nourishment placement, sand placement, and then plantings that exist, but it's pretty drastic difference. Here's another location at that same part where the park interfaced adjacent to a road. Existing conditions with significant erosion, and then after placement of the hybrid cobble berm approach. So that beach is a great example of what was there existing and then enhancing that through that nature-based approach. How do these cobble berms work? Here's a typical example of a profile. The vertical extent of this is a little exaggerated, meaning that you don't necessarily see a ridge that high per se, but it does demonstrate kind of the nature of how things move and work. And so normally what happens with very sand rich beaches is that during the winter or during an episodic storm condition, you'll lose sediment. And I shouldn't use the word lose, but you would lose sediment from the dune, but basically means it's transformed or taken offshore. And why the beach does that is it's this natural way to protect itself from the bigger waves that are coming in during the winter storm events or winter in general. And it's basically creating an offshore bar to break the wave energy further offshore before it gets to the beach. Now, that sand generally comes back on shore during the summer or sometimes is moved down along shore due to the prevailing wave climate that might exist. The cobble berms and the cobble beaches don't work the same way. What that usually happens there is they'll be transported landward or inland during the larger winter storm events. So you'll see cobble generally move inland where the sand is moving offshore to protect it. The cobble is moving more upward under that wave energy approach. What they do is they dissipate the wave energy along the shoreline, especially the upper part of the shoreline. They're not static, so different than, say, a coastal engineered structure like a seawall or a revetment. Cobble berms are allowed and are intended to move. And just because they're moving, that does not represent a failure in that cobble berm approach if that was constructed there. That is just the natural adaptation of the beach. Again, it's a nature-based approach, so it's trying to mimic what happens with nature and enhance that. And so we want these cobble berms to move. They're sometimes called dynamic approaches because they are able to move under the various coastal processes that affect the shoreline. Just an example of a site. This is one of the kind of the first anthropogenically constructed cobble berms. This was Cape Lookout State Park in Oregon, and just wanted to show the transition of what it looks like. This is post-construction in both cases. And you're looking at the winter kind of view of that, where you can see the cobbles on the beach where the sand gets pushed further offshore, higher energy waves. And then you can see on the right-hand side, the summer view where that sand comes back in and covers the cobble. Cobbles, again, you can see in the winter view tend to be pushed upland or move inward, and the sand is pulled offshore and then returns in the summer. So they work a little bit different than a typical sand nourishment approach would perform. Again, this isn't just a case where you just place material on the beach or put a bunch of cobble down and say, hey, there you go, I'm done. There's definitely design considerations that go into the creation of these. They're not, again, just a dumped pile of cobble. Certainly have to consider what coastal processes that are at play at each site. That means waves and tides and currents, what are going to affect the movement of the cobbles. What type of energy do you really have that dictates not only the size, the grain size that you might be using, but also the volume, how many layers, what elevations, the thickness, dimensions, all those go into play. Do you need a hybrid type approach like at Coughlin Park did have integration of both dune reconstruction and cobble berm placement? It wasn't just solely cobble berm. Is there storm water level management that you want to think about in terms of flooding? They can be used for that, although their primary intent is for dissipation of wave energy. And then a key thing that gets sometimes overlooked is the actual grain shape. The angularity of the cobble is very, very important. So you want a rounded cobble as opposed to an angular cobble. So I just have a picture. These are both from a quarry. You can see more of the crushed rock or angular cobble on the top and the more rounded cobble on the bottom. The reason you want the rounded cobble is you want the cobble berm to be able to move and adjust to the wave energy. What happens with the angular set cobble is they tend to get locked into place and become more of a fixed system, which doesn't really allow it to work as intended and won't dissipate the wave energy in the way that is needed. So you really want to think about rounded. We've had to reject certain cobbles in cases because it wasn't rounded enough for a particular design or site. Part of what we're doing as part of the CZM grant is monitoring existing cobble berms that have been placed across the Commonwealth. Here's the 6 sites that we're looking at: Coughlin Park, Bayside Expo in Boston, Coughlin Park's in Winthrop, Powder Point Bridge and Duxbury Beach Reservation, 2 sites of cobble berms and mixed grain size approaches in Duxbury, Mass. I should say Trunk River. The T got cut off there, but this is in Falmouth, and then Stonewall Beach out on Martha's Vineyard in Chilmark, Massachusetts. What we're doing as part of this is we're doing a very detailed, robust monitoring approach here, looking at the geomorphic change. So that means, how does the cobble berm move, function? Where does it go over time? How does it adjust? We're looking at the habitat that exists in these cobble berms and comparing that to control sites where there's not a cobble berm nearby. So rocky intertidal habitat surveys. A couple of the sites in Duxbury and in Coughlin Park have adjacent salt marshes. So we're also surveying those to identify if the placement of the cobbles has any kind of negative impact on the salt marshes in terms of extent or density. And then we're also monitoring the coastal processes at the sites to identify what happens during certain level energy events. If you're doing a project as a cobble berm, you don't have to do this level of robust monitoring. What we're trying to do here is understand better how these relatively new approaches to coastal mitigation work, function, how they could be designed better, what design parameters do you need to think about more than others. And we're doing a very robust monitoring to answer those types of questions. Individual projects that may be completed in your community or your town or city wouldn't have to go through this level of robust monitoring. That's why we're doing this right now, to help answer those questions. Some monitoring is always recommended and might be required, but it would be very simple in terms of observational pictures or surveys once a year, geomorphic change surveys once a year that can be done very easily and simply, just to keep an eye on what's happening and going on. Generally, these don't require significant maintenance. The one in Duxbury was reconstructed after about 15 years of time. So they generally work and function fairly well. Just some of the results of the monitoring, and these are early results. We're still monitoring. We have one more monitoring round to go. In terms of the habitat area, there was a lot of different types of habitat monitoring that was going on at each of these locations. And what we've seen so far at 4 of the locations that we did do the monitoring, actually 5, the only one we didn't do it was out on the vineyard, was compared to the control sites next door, the berm sites are actually showing an increase in total species richness. It's actually been a positive impact. So in some respects, because they're mobile, there was thought that maybe the habitat wouldn't really exist there, or might be worse than the control site, but it really doesn't seem to negatively change the ecological conditions. And again, we've seen so far an increase in that species richness. From a geomorphology perspective, or basically how the beach is moving, we've been doing a lot of information gathering on both the surface grain size distribution and also the elevation that you can capture via special photogrammetry and drone work that we've been doing. And you can see here from the figure, this is just looking at cross-shore profile at the Trunk River location. The red is the initial profile in August of 2023, and then we go yellow to green. What you're seeing here is basically that idea that cobble in the Cobble Beach and berm is actually moving landward as opposed to seaward. So landward would be to your left, more seaward would be to your right. Here's the water levels down here. Again, most of that cobble observation is happening above the mean high water line. So we're talking, this is a storm-based movement that's occurring. And again, it's moving landward as opposed to seaward. Now, not every site are we seeing that movement, but in wave-dominated sites, that's almost exclusively what happens, is that those cobbles move landward as opposed to seaward. We're also able to look at kind of that grain size distribution. And this, again, going from top to bottom is through time. And you can see at this little black line here, what we're seeing is actually a coarsening of the grain type. We saw some pretty significant storms over the winter of 2023, early 2024. And what we looked and identified in terms of grain size is at that location of more coarsening of the overall grain size. Again, a lot of the cobble is getting moved landward, the smaller grain size distribution. And so we're seeing a larger or coarser grain size formation over time as the beach over the winter season, again, tries to protect itself and dissipate that wave energy. Salt marsh results, again, early results here. We have seen really very little change in the salt marsh in the areas where we have installed the cobble berms. And again, we're comparing that to control sites where there's not a cobble berm. And so we do see some erosion of the salt marsh, but that a very similar erosion is occurring at the control sites, which is indicative of winter storm events or changes in wave patterns at these locations. But in terms of the loss of salt marsh in these areas, it's to be expected since the cobble generally does not move seaward to then impinge on the salt marsh. It's actually been moving landward that we're not seeing significant influence on the salt marsh extent or health or density. Sometimes we get the questions about, well, how does this compare to, more traditional coastal engineering structures like a revetment or seawall? And one thing, that is really critical is how it reacts to those storm events. So again, the most obvious thing is we are talking about a fixed versus a mobile system, right? So seawalls, revetments are very fixed in place. And what that does is they're not allowed to adjust. The beach itself can't move or react to the incoming storm events and the energy it feels. It's just stuck and left to what it's fixed in place with the structure. What that means is you get a much different reflective versus dissipative environment. So in those structural cases, you get very reflective energy, is kind of shown in the upper picture here, where the wave will come in, hit the fixed structure, and then a lot of that energy is reflected back or bounced back onto the shoreline. Sometimes it's also thrown over the structure, which can have some consequences as well to the seaward side or the landward side of the structure. And then in a cobble berm setting, you get a much more dissipative energy where the energy is more absorbed into the mobile feature and structure along the beach. Another thing is you always at these structural situations, you get the end effect erosion where you have to end the structure somewhere and you get a lack of sediment supply for a long stretch of where the seawall beach is, and then you transfer that potential loss to the natural shoreline that exists on the end of the proposed structure. The other big thing is the erosion. So when you have that fixed situation, again, the beach can't adjust naturally to the way it would want to protect itself from those storm events. And so you'll get that erosion or scour because of that reflected energy directly in front of the seawall. And many times that can't be pushed back on shore because the seawall is there. And so you're basically moving or transferring that material somewhere else down the beach or offshore in some regards. So pretty big differences between those fixed versus mobile approaches to coastal protection. Just an example of a potential siting for a cobble berm. Again, you can notice in these existing conditions pictures, this is at the end of a seawall location in Duxbury. Very cobbly existing beach setting here. And again, the end effect erosion from this seawall, you can really see that has occurred over time. The homeowner has tried to do some of their own makeshift protection in that regard. And so one of the things we were looking to do here was this seawall was going to be reconstructed, made a little bit higher. And then how do you appropriately tie that in to the natural beach that exists to the south? And so we recommended actually removing some of the angular nature of that seawall, restoring the coastal dune to get your elevation and flood protection behind that, but then putting a cobble berm, which naturally matched kind of the existing grain size distribution on the beach in front of that elevated dune system, and then tying that in with a very short seawall segment to connect to the existing seawall to reduce that end effect erosion and allow the cobble berm to function and move in this particular location, but also bolster and protect the dune behind it. So little old school engineering and drawing here of what that looked like. So there was a cobble berm, but it was then also backed by a vegetated dune restoration project that got significant increase in elevation to provide flood protection and erosion protection on the backside, while the cobble berm was doing its work on the more seaward side of this. And this made for a good solution for an end effect condition adjacent to a seawall, as opposed to the ongoing erosion and beach lowering that was occurring normally. So just an example of a hybrid type cobble berm approach that could be used in a certain area. So with that, I'm going to turn it over, or we're going to have a quick break. I'll turn it back over to Rebecca.
Yes, exactly. Thank you so much, Kirk. And thank you everyone for continuing to put your questions in the chat. We will get to those at the end. And for now, enjoy a 5-minute break. We will be back online at 1:35. Okay, folks, hope you enjoyed that little break. Got the opportunity to stretch your legs, get a glass of water. We are now going to be moving into the real meat, the 101 portion of our workshop. So we are going to be passing things over to start with to Leslie Fields at Woods Hole Group, who's going to run us through some case studies, some lessons learned, and then we'll be transitioning after that to our colleagues at CZM. So with that, Leslie, you are welcome to share screen and take it away.
Thank you for that introduction. So I will be talking about 2 sites that you've already seen some photos from these sites, but 2 sites where cobble berms have been designed, permitted, and constructed to effectively control erosion at the 2 sites. So the first site is Coughlin Park in Winthrop. That's the top photo up there. And then the other site is Duxbury Beach Reservation in Duxbury. Some of you may recognize this famous guy here in this photo, Jim O'Connell. He was involved in some of the early work at DBR in designing and implementing the cobble berm that they have there. This is what Coughlin Park looked like pre-construction. It was essentially a site where there was a lot of erosion. They had erosion on the rate of 1.4 feet per year, which is pretty high for this area. That exposed that coastal bank that you see in all 3 of these pictures. And then that was therefore threatening the park, which was behind the site, as well as Bayview Ave, which is shown in this picture on the lower left, which provides access to a number of homes in this area of Winthrop. So again, this was primarily for erosion control and not for flood control. One thing I wanted to point out is that I really think it's important when you're designing these types of projects to go out and delineate and map the resource areas that are there. And I know that we always do that for all of our projects, but I just want to emphasize that so that you can minimize impacts to some of the sensitive resources. So at this site, over on the left in the park area, we've got land subject to coastal storm flowage. And then sort of moving from left to right, we've got a coastal bank here, the backside of the beach. Then we have a coastal beach. And that is a beach that has cobble and gravel in the upper part of the beach. And then it's a sandier sort of beach in the lower areas. So as Kirk was pointing out before, it's a composite beach. Much like he was showing in some of those slides before. And then moving seaward from there, we've got some rocky intertidal in some areas here. You're going to notice some chunks of concrete from some previous project that I'm going to talk about in a second. And then at the seaward edge, we've got salt marsh. And so this was a site that had really a lot of different resources, and it was pretty complex. And we wanted to design this project so that we weren't going to have any impacts to habitat areas for shellfish in the lower part of the beach and this salt marsh out here. This slide here shows the design. This is a project that was put forth by the town of Winthrop. Woods Hole Group handled the engineering and permitting, and it was funded by a cesium coastal resiliency grant, several grants, I believe. It is a hybrid cobble berm approach. So it starts with the fiber roll array, which was placed along the face of the coastal bank. Those fiber rolls were anchored with duckbill anchors. And then seaward of that is where we put the cobble berm in the nourishment area. And so cobble berm was put out there to protect those fiber rolls and continue to provide erosion protection for the bank. And then behind the top of the bank, we had a vegetated buffer strip that was vegetated with native species. A couple of design considerations we included are shown here. So to ensure that we weren't going to have any impacts on the salt marsh, we did establish a 50-foot setback from the salt marsh. And that was to minimize potential for cobble redistribution to the marsh platform. I believe since this project was built, and all that monitoring that Kirk showed, we're really seeing really no seaward movement of these cobbles, but more landward movement. So that was something I think that was, learned, right about the time this project was permitted. Most of the work was held above the mean high water line to avoid impacts to that intertidal shellfish habitat in the sandier portion of the beach. That's something that DMF was concerned with and requested that we consider. One thing to note about this project is that the high tide line, so the Corps' jurisdiction, falls somewhere on the face of this bank. And so major portion of the cobble berm nourishment was occurring within Corps jurisdiction, in those areas, say the intertidal areas between high tide and mean high water. The Corps wanted us they wanted to see some sort of mitigation for placement of this cobble berm material in that area. So one of the things we did was agreed to remove some of that concrete debris that was out there in the previous slide that I showed you as a way of mitigating some impacts from this cobble berm in that area right below the high tide line. And then we chose to really maintain, I guess, the slope of the existing bank with the design rather than pull it back and try to remove the whole project outside of the Corps' jurisdiction just to avoid having to get a Corps permit. We didn't feel like that would really replicate what was there on site and chose instead to work with what was on the site and go ahead and get the Corps permit, even though that's an extra step. In terms of permitting, this particular project required us to file an environmental notification form with MEPA. So we needed to get the secretary's certificate on the ENF. That was triggered because we needed a state permit and because the project involved alteration of a coastal bank and fill in a velocity zone. We were also required, so we did file that. We did not have to get an EIR though. We were found to be exempt from having to get an EIR. We also were required to get an order of conditions for alteration of a coastal bank, coastal beach, and land subject to coastal storm flowage. We did also need a Chapter 91 license. So the reason we had to get a Chapter 91 was because the project site is on filled tidelands. The fact that we were using those fiber rolls in addition to the cobble berm was the reason that we had to get the license with Chapter 91 as opposed to the permit. I think the cobble berm by itself, without those fiber rolls, would have just required a Chapter 91 permit. But again, because we had those fiber rolls, we went for a license. And then we need to get an Army Corps of Engineers general permit because we're filling in waters of the U.S. That involved consultation with National Marine Fisheries and U.S. Fish and Wildlife. Again, that's where that idea of trying to mitigate impacts in that area right below the high tide line came about, and that's how we removed the concrete debris on the beach. I just wanted to point out now that with the new general permit that came out with the Army Corps of Engineers, this particular type of project would more than likely fall under GP 7, 9, or 20. And so it's worth it just to read, those descriptions in that general permit to see if your project, if you're designing one of these, falls within one of those general permits. This project was constructed in 2019. We used 3 to 7 inch cobble, and we were required by the agencies to do grain size testing of what was on site before the project, and then with the source that we identified for building the project. And we also had a monitoring program that we proposed for this project that the regulatory agencies wanted. The stakeholders also wanted this because, again, it was a CZM funded project. It's one of the earlier ones in the state. And so, we all wanted to be able to collect enough monitoring data on this site to be able to evaluate performance and to evaluate if maintenance would be needed in the future. And that monitoring is really pretty simple for this particular project. It involves some visual monitoring and a couple of beach profiles like twice a year. So it's a pretty simple sort of monitoring protocol. All right, the next project is at Duxbury Beach Reservation. This is on the bay side of the road that goes out to Gurnett-Saquewish. This again is a project or an area where erosion is a problem. So erosion of the side of the road, wave activity has the ability to get under here and undermine the road, as well as some sort of current velocities. It's got a considerable sort of west-facing fetch, which allows some of the waves to get fairly large and cause erosion of this area. In terms of the resources here, this site's a little bit more simple than the Winthrop Coughlin Park site. We've got a coastal dune barrier beach back here on the road on this side. Then we've got coastal beach. Again, this is mainly cobble and gravel coastal beach, a lot less sand than what we saw at Winthrop. The whole area is estimated habitat of rare wildlife. Okay, and this slide has some of the design components. The applicant's Duxbury Beach Reservation, this is their property. There have been a number of consultants who have worked on both the engineering and the permitting. And there have been a number of projects out here that have been funded either sort of private funding through DBR or through CZM coastal resiliency grants. So the original construction for this project was a long time ago in 2002. So I guess this was probably one of the first cobble berm projects, in the state. Since that time, it's been restored 5 times, 2006, 11, 20, 2015, and 2022. In 2000, I think it was originally constructed around 1,800 linear feet. And then in 2015, it was extended to 2,000 linear feet. The CZM funding was in 2020 and 2015. All the others were funded privately by DBR. In terms of design components, it's basically adding cobble back to that beach area at a slope of 3 to 1, bringing it up to the elevation of the road, using 4 to 8 inch diameter cobble. The whole project is held above the high tide line, so mainly to minimize impacts to those intertidal resources. In terms of the permitting, originally this project really just needed an order of conditions. It's alteration of coastal beach, barrier beach, and land subject to coast storm flowage. It has been sort of re-permitted several times, and more recently, when it was re-permitted, it was lumped in with some larger projects. So bigger beach nourishment project on Cape Cod Bayside, another cobble berm project under Powder Point Bridge. And so at that point, it went through more extensive permitting with MEPA and with Chapter 91, as well as Army Corps of Engineers. But I think, just alone, if you can hold this project 2 areas above the high tide line, then you're only going to need that order of conditions. And then this is the last slide I have, just some lessons learned from all these projects. As I pointed out before, I think it's really important to identify and map those wetland resources that are on site. and to try to include design elements that will help avoid or minimize impacts to sensitive resources that DMF, National Marine Fisheries, and Fish and Wildlife are going to be concerned with, as well as DEP, so salt marsh, shellfish habitat, things like that. I think it's also really important to quantify the area of impact each resource area and to illustrate that on the cross sections on your plan. So are you only working in coastal beach? If so, how many square feet? Are you on coastal bank? If so, how many square feet there? How many linear feet of bank are we impacting? The seaward spread of these stones or cobbles into any sort of sensitive resources, we think could be minimized by designing these features with more natural slopes and by using compatible cobble sizes as to what's on the beach. We are recommending, or we do recommend, monitoring once or twice a year. We think that's important to both evaluate performance as well as the need for renourishment. And they shouldn't really be thought of projects that, it's just one and done. You build it once and you're done with it. I think it's important when you're doing the permitting to include the ability to come back and renourish as needed. So in other words, to include maintenance in that permit application to allow for this renourishment as necessary based on the monitoring that you're doing. And that monitoring can be pretty simple. It can be visual. You can do beach profiles, topo surveys. It doesn't have to be a big complicated monitoring program like Kirk described before, because that was more for a research basis and trying to help with the design of these features and siting of them. So it can be really pretty simple. And I believe that's my last slide. Yep. So I don't know if Rebecca
Yes.
wants to add anything or.
Yeah, I think our folks at CZM are on deck next, and certainly during before we open it up for Q&A, if anyone else wants to add any pieces from our speaker panel, you'd be welcome to. Again, folks, do keep putting those questions in the chat. Really appreciate everyone adding those in. So for our final chunk of speaking time, I'm going to pass it over to Julia Neisel at CZM.
Thank you, everybody. I'm happy to round out the speakers. I'm going to take a few minutes to emphasize some of the state policy and programs that support this work and talk about our coastal resilience grant program and some other resources that are available to help guide you in these projects. So I want to start by highlighting the executive order on climate change that was released back in 2016. This was one of the early statements on nature-based approaches. As you see here, the executive order specifically speaks to using the natural resources of the Commonwealth to enhance climate adaptation and build resilience. We then provided more detail on nature-based solutions when we updated the State Hazard Mitigation and Climate Adaptation Plan in 2023, also known as the Resilient Mass Plan. What I have here is the goal for communities and ecosystems in that plan. And as you can see here, we now speak more comprehensively about all of the benefits of nature-based approaches, not only focusing on the community resilience aspects of managing coastal erosion and flooding, but also speaking to those other co-benefits of environmental health, whether it's water quality benefits or coastal habitat. And then also really emphasizing the ecosystem functions, the ability to attenuate waves and for the system to shift and migrate. And then also recognizing that as sea level rise accelerates over time and we continue to lose sediment from our systems, we need to recognize that and make sure that we're designing projects that are resilient in and of themselves, but also have a commitment on the part of the project applicants to make sure that there is a maintenance plan built into the project. The Coastal Resilience Grant Program that our office manages launched back in 2014, and we're very happy to provide financial support in the form of grants, and then also our technical assistance through our shoreline and floodplain team and also our regional coordinators. And we have grown the program. Initially, all of our 78 coastal communities were eligible for grants. And then we expanded to include landowning nonprofit organizations. And as of last year, state and federally recognized tribes are also eligible to apply to the program. And in terms of the types of projects we're talking about here, we are able to support cobble berms, beach and dune nourishment, coastal bank stabilization, as well as fringing salt marsh projects that help stabilize eroding systems and protect community infrastructure. And another project type that is eligible but hasn't been advanced yet in the program is looking at living breakwaters as well. So with all of these projects, we are really looking for a strong project team that not only has strong community partners, but a qualified consulting team and integrates the CZM technical support into the process. And all of those individuals will help provide guidance on appropriate grain size, slopes, monitoring, all of the components of the project. We do want people to focus on the impact of sea level rise and how that is being considered into the grant projects. We have a grant viewer that shows all of the projects that we funded over the years since 2014. And the viewer has been upgraded recently. So now you can filter all of the different projects. And what you have here are the shoreline stabilization projects that have been constructed in Massachusetts. So we've awarded over $16 million for implementation projects. Most of those are beach and dune nourishment projects, but as Woods Hole Group describes, we also have a few cobble berm projects that we funded as well. If you click on one of the dots in the viewer, you will get more information on that project. You'll find out how much the project costs, whether it was in the design, permitting, or construction phase, who is the primary lead on the project. And then we also have links to additional resources. This particular example here, the cobble nourishment at Plymouth Long Beach, the link leads back to our website and a featured case study that we developed on this project. I really encourage you to explore the viewer, to look at all of the different types of nature-based projects that have been implemented, and reach out to us if you want to be connected with the community leads from some of the other projects, or you want to see design plans to help your thinking in developing a project. I want to underscore the importance of public engagement and education. Clearly, community members need to be involved throughout the planning and design process, but we don't want to miss the opportunity to also use the site for public education. And we highly encourage interpretive signage when people are implementing these projects. There's an opportunity here to increase the understanding of community members of the function of the ecology of the system, and also give a little history about the evolution of the site. So please strongly consider opportunities for public engagement and education. And then finally, I want to emphasize that Massachusetts is working with the other New England states on trying to promote the application of nature-based approaches. And the way that this is being conducted is through the Northeast Regional Ocean Council. And I have a couple resources highlighted here. Both of these documents were released back in 2022 and were supported by NOAA. The first one lays out some guidance on the regulatory triggers for projects and provides some information to help you think about how those regulatory requirements apply to a project. And then the second document, the monitoring document, does a nice job of laying out the range of parameters or metrics that could be monitored in a project and links out to protocols. And these span sophistication. Like some are very simple, some might require instrumentation and more experience with monitoring, but it's available as a guide if you want to learn more. So with that, I want to get us back on track to open it up for our discussion.
Wonderful. Thank you so much, Julia. So before we jump right into our Q&A portion, just wanted to let folks know that as part of this grant project that the Stone Living Lab, Woods Hole Group, DBR, and CZM are working on, we're also developing, just as Julia mentioned, some of these outreach and education materials. So one of the pieces which I put the link in the chat a little while ago, we'll put again, is an interactive story map about these cobble berms, where you can even see some of those nice transitions that Kirk had highlighted in his slides of seeing the befores and afters. We're working on developing a series of simplified fact sheets. So this is a preview of one of monitoring basics, Cobbles 101, and top 10 factors to think about when you're considering a cobble berm for your project. We're also working on some educational videos. So we'll be putting out videos that will actually introduce folks to Duxbury Beach as one of our highlight sites, as well as more information and really the opportunity to see video of cobble berms in action in the field, really performing as we hope they will. So as we move into the Q&A portion, I just want to remind folks of our guidelines here. So we're at first going to be pulling our questions from the chat, and then we may be moving into folks raising hands and asking questions verbally if we have time. So I just want to remind folks that we embrace speaking in the first draft, assume best intent, avoid using the chat for side conversations, though we will be putting resources in there. So do feel free to peruse some of those links for later. Be respectful of the speakers and your fellow attendees in terms of questions and timing, as well as language. And we just do ask that you remain muted unless you are called upon. So with that, we have some questions that we're going to move to into the chat, and some of them are specifically to folks. Others we will, leave open to any of our illustrious speakers here. So one of the things that I think we get this question a lot, and it's one that's probably on a lot of folks' minds, is about cost. So in these projects or in other projects, we also include some of this information in our story map. What is the total cost range for one of these cobble berm projects? And I'll leave it to maybe our friends at DBR or Woods Hole Group to answer that.
Yeah, this is Kirk. I can answer that question. So of the cobble berms that we've designed and constructed, the actual construction cost has ranged from about $40,000 to upwards of $200,000. Again, depending on the type of cobble, whether it's a hybrid construction. So for example, the ones in Falmouth and the renourishments in Duxbury are on the lower end of that scale. The Coughlin Park, which has the hybrid solution, was much longer stretches at near the upper end of that. So that gives you a good idea on the range of the construction costs for those.
I'll add that for our Coastal Resilience Grant Program, we also support the design and permitting. And typically design and permitting for these projects can be, you know, 100 to 150 to $200,000 for design and permitting, depending on the scale and complexity of the project.
And you guys also cover the part of the construction cost on a lot of these as well. So there are grants available, both from the state and in other cases, federal level to do some of these nature-based approaches, both design, permitting, and construction.
We have a project cap of 2 million, and we had waived match in the last couple of years for projects. However, we're bringing the 25% total project cost match back this year. So I do want to emphasize that.
Perfect, thank you. And another great nitty-gritty question that just came in that I want to offer up to the group is, has it been difficult, or perhaps how does one source appropriate cobble materials for sites, and is it sourced locally?
I might be able to add something to that, but I think others here probably have opinions as well. But can it be difficult? Yes, it is difficult. Sometimes there are contractors or you know, materials facilities that have stockpiled cobble. You have to be careful in those cases that it's the rounded sort of cobble and not angular, as we were talking about before, because sometimes they will create it, and in that case it's you know, more angular. We were recently able to get some cobble from a site where they were doing some excavation. And so it was a nice mixture of both sandy material, gravel, and cobble. So in that case, we sort of lucked out. But I think if you have one of these projects coming up, I think it would behoove you to start searching for cobble soon, you know, early in the process, and go and visit sites. Go visit sites where there's excavation going on. Go visit sites where the contractors say that they've got material stockpiled. Go and visit and take a look at it and see if it's suitable for your site.
Yeah, I can add to that. Some project managers have worked with the sand and gravel pits to screen out the cobble materials and accumulate that over time for a project, so that you give them a little more lead time. Sometimes that helps, as the coarser material is in the glacial deposits. They screen it out as they go instead of crushing it. If they know to save it, then you can get that a little easier. But if you're putting a project out to bid and expect it right away, it makes it a little more challenging. Sorry, Kirk, you gonna say something?
Yeah, no problem. I think I was just talking about the sourcing. Most of it has been sourced locally for these projects. And so again, to Leslie and Rebecca's point, if you're on top of it early, I don't think it's quite as difficult, but you have to be on top of it early. So that piece of it. And then, you know, I think one question comes in about the rounded versus angular. As mentioned, you know, it's really critical to have those rounded based cobbles so that they are able to move appropriately. If you have the angled cobbles, those can get locked together. If you think about kind of you know, angles that can match up and form more of a solid structure, they don't move as well under the wave environment. So the angular based crushed rock doesn't really work and becomes more of a fixed system than a mobile system, which is what we're trying to avoid in the design. And the last thing I'll mention is just on slopes. Leslie talked about, you know, trying to stay above mean high water line. That doesn't mean you should do that all the time. The design of these things and the slopes are really important. There needs to be a natural slope that works for the cobble berm. So don't over steepen it in terms of the design, just to avoid potential regulatory pieces, because that would be not a well-performing system. And Coughlin Park is an example where we purposely did not try to stay above a certain regulatory threshold because we knew that it wasn't going to work at the slopes. And so don't over steepen these things is a message I would say about the design.
I'd just like to add from a timing point of view, getting the material to put some real dates behind it. We were looking to do a project in September after the plovers left, and we were looking to source in March. And if we had continued with that source as going with sand and gravel, as Rebecca's saying that they sieve and put it off to the side, they wouldn't have had the product that we were looking for by the time we needed it. So we've been trying to partner with contractors working on developments and sites and doing our own sifting from that product. So the minute you think you want to do this, and you really need to not only just go once, but we would go in and check on the product to make sure it didn't accidentally get sent to another place or at a higher price, or it was the right size. Because the bigger your range, you wind up getting usually the smaller sizes if you're looking for larger, or vice versa. So mark it early, go back, and then by the time you're finished with your project, start to plan on when you need to do maintenance. Because the longest time is actually finding and sourcing the product for us. And that's saying something when permitting takes a long time.
Perfect, thank you. So we had a question here about the sediment, the native sediment, as we would call it, at a site. So does there have to be a specific percentage of cobble on a beach to be considered eligible for a cobble berm project? Another way of asking is, what does the natural landscape need to look like? What is the amount of cobble that's, all right, we can put a cobble berm versus another kind of restoration?
I can take a stab at that. So when you're looking at a site, as you noticed in Kirk's photos, there's changes in the cobble distribution you see on the surface from winter to summer. So understanding what the natural distribution is in the whole system is important. And then at Coughlin Park, we had a natural cobble berm further down the shoreline, but in the area where there was erosion, there wasn't as much. So it's understanding what's in the whole system and the context for the shoreline, whether you're tending to get those small cobble berms forming versus just a few rocks here and there. So this concept is generally, consistent with the state DEP's guidance on best management practices for beach nourishment. You just need to characterize the system and keep in mind it's not just a superficial sample, that there is quite a distribution in the system. So there's no magic percentage answer, unfortunately.
Yeah, and I'll just add, you're looking to you're looking at nature to understand what the existing beach is to help guide that, as well as wave energy. That doesn't mean that you couldn't consider things, but it's very site specific, right? And you have to assess what's going on. Like there's a couple sites in Oregon where it was, a compound beach that was added for a very specific reason. So you take it on a site by site basis, but certainly use the natural beach as the primary guide for that, with some influence of the wave energy and types of energy that exist at a beach, whether it's tidal based or wave based.
Wonderful, thank you. And sort of with that topic of the wave and tidal energy, we had a few questions. So I'm gonna kind of combine these into a single question about the cobble migration. So Kirk, you had talked about that cobbles primarily migrate landward. And so when you're designing a space or designing a site, how much of a range do you need to consider in terms of that landward movement? And then how do you design thinking about, okay, we've got some inland resources that could be effective. How do you consider sort of that landward piece of the project?
Right. So a lot of things to talk about there. So first of all, from our monitoring, we've seen, a net movement generally of stuff landward, but not at every site. So the Duxbury site on the bay side is an interesting one where we see less net movement landward and more spreading kind of across the shore face. However, that one is right up against a tidal, a navigational channel, and it's very strongly driven by tidal currents. That doesn't mean that bay beaches aren't wave dominated. It's that particular beach has a very unique setting that has highly influenced tidal currents in it. So it's a unique setting. Most of the other ones show either movement landward, or in the case of Coughlin Park, has really been very non-moving, but that's primarily because we've had lack of storms and stability. In terms of how to design this in terms of an overall inland thing, it obviously it depends what's on the site, what you're trying to do. But for that example I showed at the end of that seawall terminus, right, we are aware that cobble is going to generally try to net move in the landward direction. So we bolstered that with a natural dune elevation behind it to allow the cobble to move, but not completely go over the top of the barrier beach, and hopefully have the dune there for storm water. I mean, for coastal flooding benefits and for reducing the overall movement, but still allowing the dynamic movement of the cobble berm itself to do what it needed to do. So you do have to leave some space in areas. In other areas like Duxbury along the road, it went right up to the road because that was what was needed for the protective element. So again, it's a site specific thing, but there are hybrid approaches that you can do to help handle that interface between the ocean and your land.
Wonderful, thank you. I think you'll hear again throughout this, you've heard through this presentation and through the Q&A that everything is site specific. We know that our coasts are really dynamic and diverse places. And so there's guidance, and then eventually you do need to sort of get boots on the ground and start to consider all the different impacts at your site. We had a question that was particularly about invasive species and monitoring. So I'm curious if any of you have noticed this or observed this in monitoring, which is, have you noticed any differences in invasive species populations between control and berm installation sites, including before or after installation? So for example, Asian shore crabs can live in the high tidal zone, and they also really thrive in cobble environments. Is that an effect that you all have seen in your monitoring?
So I could probably answer that, although I'm not the biologist, and will readily say that otherwise I'll get in trouble with my wife, who will tell me that she knows way more about biology than I do. What I do hear from the biologists that have been doing the habitat monitoring is that predation at the sites, both the control and the cobble berm locations, was dominated by green crab, which are an invasive species. However, there was no difference in the count or number or anything that they saw between the control sites and the berm sites for the crabs, both green or Asian shore crab. So again, some early days in the monitoring output there, but they have not seen differences between the control sites and the cobble berm sites for those particular invasives. Can't say much more than that. It goes beyond my expertise. So.
And that's why monitoring is so important. So this is still something that we want to continue to gather more data on and learn more about. So we're going to move a little bit into a permitting question, which I think we all know and understand here that the permitting world is a complicated one. So we had a question here about sort of the permitting landscape. So we know that permitting is complex, especially when you're coordinating with multiple jurisdictional agencies. And with the current regulatory framework, it can be difficult to put material into a coastal resource area. So based on the resilient mass goals that Julia mentioned under Executive Order 569, what are your recommendations about when considering nature-based approaches in this complex regulatory environment? And I'll leave that to any and all of you to answer.
I think I was covering it a little bit before, referring to the DEP practices, best practices for beach nourishment in Massachusetts, that this is very consistent with that. It's mimicking nature, as Kirk said. It's adding to and complementing what's already there in the system. So it's along the lines of beach and dune nourishment, but with appropriate compatible materials. So as Julia said, we are very supportive of beach and dune nourishment and nature-based approaches. And this is a complement to that, just mimicking what we naturally have.
Okay. So we had a question that was particularly about Duxbury Beach regarding the slope. So this one's a little bit into the technical questions here, but so this person asked about with a slope of 3 to 1, does that see more movement of cobbles, or does that result in more maintenance or replenishment needs because of that specific slope?
So we were still digesting all the geomorphic survey information for Duxbury Beach. But as I mentioned there, we have seen more seaward movement at that particular site. I think it's a lot due to the physical processes that dominate that at that location. But we're looking into the slope piece of that as well a little bit more. So it's a good question that I don't think we have a full answer for quite yet.
Yeah, thank you. And another specific question that actually digs into a little bit about wave height and sort of tidal range. And so one caveat with this for the person who asked, they wanted some specific information with regards to the project. And so I would encourage anyone who has like very nitty-gritty questions to please feel free to reach out to any of our speakers here. But there was a question, part of this question that was about wave heights. And so where in terms of wave activity as a site at a site, is there a site where it's just too much wave energy and it's somewhere that this isn't going to be appropriate at all?
So I'll take a shot at that one as well. So we're figuring that out. So one of the sites we have, which is Stonewall Beach in Chilmark, which has a very predominant natural cobble berm at the beach, has larger than average cobble there. And that particular site and that cobble berm that was constructed there, it is very high wave energy. So that's on the open facing southern Atlantic shoreline of Martha's Vineyard. So the cobbles are larger, and the wave energy is very, very high, as you can imagine, during storm events. So we're learning more about what and how that works and what the upper limit might be for energy from that perspective. So we actually have a site where it's pushing the bounds, I think, of the energy piece. That being said, there is a natural cobble berm that is formed there pretty extensively. And it is one of those kind of composite beaches with sand in the summer and then very large cobble in the range of cobbles in the winter. And so we'll see what we get from that. I think we have a good spread of sites of the ones that we're monitoring in terms of energy. So some of them are a little bit more quiescent. Some of them have more waves associated with them. And so we'll figure that out. So it's about as big a wave as you can get for the Martha's Vineyard one from my perspective.
We also have a really good example in Situate of a natural cobble barrier beach with a large cobble dune that's pretty high wave energy, very exposed in Situate. So, and that's functioning quite well.
Yeah, so as of right now, I don't know if there is a limit. We'll see.
Perfect. Thank you. So we just have a few minutes here before we wrap. And so I wanted to offer a final question to this whole group, which we've talked a lot about some lessons learned, what to do when designing, things to consider. But I'd love to hear from anyone who would like to answer. What is the number one thing not to do when you are starting off on one of these cobble berm projects? If you were to tell someone, don't do what we did, what would it be? Yeah, go ahead, Chris.
We didn't do this, but I learned from another, and that whenever you talk about a cobble berm or even a nourishment project, use the word maintenance in it. To set the tone at the very beginning. This is not a one and done. So when you go to Concom, when you go for your permitting, you're already teeing it up that you're gonna be back. And then when they look back on it, you can say that, oh, it wasn't because it was a failure or it's a new project. It's a maintenance of another project. I think that's probably the biggest thing that I've learned in all the work and permitting that I've done. Throw the word maintenance in.
Yeah, from my perspective, not looking to the existing conditions that are on a site is a starting point and as a guide is really important. And then also not just, saying, well, I can just dump some cobble here, right? It has to be designed. It can't just be dumped and expected to really function correctly. It might be, something you would do in an emergency situation per se, but to really get these things functional, you need to have a design. And I would say that would be the case for sand placement as well. You're not just going out there to say, hey, I can fix this problem or mitigate some issue by just dumping some material here. So that's one. You got to think through the slopes. You got to think through the volume and the sizing and all these types of things to really come up with a project that's going to function as intended and work appropriately.
And I think you want to think about setback to other resources like salt marsh, making sure you have appropriate slopes, you don't want to oversteepen it, and the appropriate grain size. Trying to keep it above mean high water, but not oversteepening it to do that.
Time for a funny one. Take twice as many buckets when you're doing sampling because you're never going to be able to pick up a 5-gallon bucket full of cobble.
That is perfect. That's the kind of lessons that you only learn when you are truly out there doing it. Well, thank you all so much. We just have a few little wrap-up pointers before we release you all for the day. Just want to give a big thank you to our speakers, Kirk, Leslie, Rebecca, and Julia, and Chris from Duxbury Beach Reservation for joining and adding some of that much needed on-the-ground perspective as well. And so I just want to share with folks before we head off into the rest of our afternoons that we have one more of our field trips left this spring. So we will be having a field course on May 8th in Hull. This will be focused on cobble berms in action, site exploration, and municipal panel. So we will be having a panel with some of the folks from the town of Hull talking about the considerations that they have gone through to begin exploring a cobble berm at the site. And then we will go down and check out the site itself and really be able to get our boots on the ground and explore. So please do sign up for that if you are able to join. I'm going to ask if Annie, if you're available in the background there to put that link in the chat. And then really just, thank you all for coming. This is part of our outreach and education portion of this grant, is really getting this information into the hands of folks like you all to be able to start to learn about this really exciting technique and begin to rethink ways that we can adapt, our coastline to the changing conditions that we're seeing now and into the future. And so we also have a little survey here at the end. If you have a few minutes, just put it in the chat to fill that out. Let us know how this all went. If you have any lingering questions, you can certainly reach out to folks at CZM, myself, and others. And otherwise, we just hope you all have a wonderful afternoon, get to enjoy the sun, and we'll see you out there on the beach.